Okay, we're going to first examine the idea of what is a variable. And to understand this, imagine that, for example, you've dialed a 1-800 number, or maybe you're chatting with somebody online, and you don't know anything about the person, but you're a bit intrigued by maybe their voice or what they're saying. So you ask yourself several questions. For example, where is the person? What city, what country? Is the person tall or short? What color are their eyes? Is it a young person? By their voice, sometimes you can tell this sort of thing, man or woman, and so on. How does the person define themselves? Uh, and in this modern world, heck, is it even a real person, or are you chatting with a computer? All these various questions have answers, possibly. And the answers, in effect, are a variable. And until you know the answer, we'll just simply call it X. It's a placeholder that represents the value once we know it. And the question now is there a way to classify this variable or placeholder X? And of course, there's many ways of classifying different categories and so on. We're going to look at specifically 6 that are relevant for this course. And in actual fact, there's going to be a 7th question as well that I'll discuss at the very end. So here are the list of the questions. I'll go through them quickly right now. And whether the variable is qualitative or quantitative, whether it's a nominal or ordinal variable, for example, is it continuous or discrete, interval or ratio variable, is it mutually exclusive or not mutually exclusive, and finally, is it dichotomic or not? And we'll look at each one of these carefully to understand clearly what they mean. The last question I want to look at is the 7th one. Is it a random variable or not? And for that, I'll have to spend a bit of time talking about it. But the first 6 are the ones that really matter. So let's take a look at this first question. Is the variable qualitative or quantitative? A qualitative variable typically means that the answer to the question is going to be a word. For example, what is the person's eye color? Or where was the person born? The answers to these questions are going to be something like a country, a city, or blue, green in the case of eye color. A quantitative variable, on the other hand, typically is going to be a number. For example, how old are you? You're like 18, 19. What is your R score? It's like 23.8 or 27.1. So these are going to be numbers, typically. Incidentally, qualitative variables are also known as categorical values or categorical variables, and they're also known as factors, and in that case then their values are known as levels. I'm going to try to be consistent as much as possible, and I'll always refer to them as qualitative variables. These terms are used interchangeably. It depends on the textbook. Incidentally, we'll be using Excel, so Excel typically stores a qualitative variable as a text. And often many problems arise with Excel because it thinks a variable is qualitative when in fact it's quantitative, or vice versa. Computers generally refer to a qualitative variable as a string. Not always, but typically. They're saved as characters. On the other hand, quantitative variables, and Excel deals with them very differently, deals with them as a numerical value. And again, it depends on what type of numerical value, but there's a big distinction for computers between these two types of variables. It's important to have a clear understanding of what they are. Be careful. Sometimes a qualitative variable will have a number in it. For example, model numbers. iPhone 6, well, there's a 6 there, but there's also, of course, the word iPhone. But in the case of cars, I think the C280, that's a Mercedes-Benz, there's the C, but simply having a number doesn't mean that it's quantitative. It could be qualitative. At the same time, we've already seen this, colors are often using a letter, like hexadecimal. So simply the fact that there's a letter doesn't mean necessarily that it's not quantitative. But in general, and I'll try to keep it as simple as possible, qualitative means it'll be a word of some sort, and quantitative means it's a number. The next question we'll look at is whether it's nominal or ordinal. Now, important to understand that this type of question, this question only applies to qualitative variables. It's not that important for this course, but make the distinction here. Nominal means that there's no natural order to the words, except putting them in alphabetic order. Ordinal, on the other hand, means there is some kind of obvious ordering to the words in terms of first, second, and third. I think I'll give you an example. This should illustrate the concept a bit better. Think of nominal. What is your country of residence? Well, that's a qualitative variable. Canada, United States. Well, you have to fill out those forms. They often put it in alphabetic order. So Afghanistan, Albania, and then have Zambia at the bottom. But they often put Canada and the United States at the top because most of the people, whatever they're filling out the form, are in Canada and North America. But this order is going to depend on the language you're using. If it's in a different language, the order is going to be completely different. So this is a nominal variable. On the other hand, ordinal would be something like the size of a t-shirt or size of a drink. If you order a drink someplace like small, medium, and large, you could list these in a different order, but it look pretty strange. So this is a variable that's qualitative, but it has some kind of natural order to it. Here's a good example: rocks and trees. Uh, if you're looking at from the nominal, like if it's a nominal variable, would be sedimentary, igneous, metamorphic. I don't know about rocks, but or trees are deciduous or conifer. There's no natural order here. It's just however you want to do it. But if you're looking at, for example, the hardness of rock, for example, I think there's a numbering system or some scheme to determine whether wood or rocks are hard or soft, then that would be ordinal if you were measuring it that way. A little point I'll make here at the end here too is that often people refer to cardinal, ordinal, or nominal numbers. Now this is completely separate, but just so you know, cardinal numbers means 1, 2, 3, 4. Ordinal numbers means first, second, third, if you're listing them that way, and then nominal numbers like a telephone number, in which it's just a mix of numbers. But keep in mind, nominal and ordinal only applies to qualitative variables. At the end, I'll have a summary of this. Okay, the next question we're going to look at is whether the variable is discrete or continuous. And important to understand that this question only applies to quantitative variables. So if you have a quality, you know what's a qualitative variable, you can simply ignore this particular question. So discrete means it's like a whole number. It's an integer, for example, 1, 2, 3, and so on. If somebody asks the variable that would represent the number of siblings you have, brothers, sisters, or how many courses you're taking, well, it has to be a whole number. You may have a little brother, but he's not a half a person. So discrete means it's a complete whole number, called an integer. Continuous number is one that has, if you will, decimals and fractions, for example. Although this is a little bit more complex, and it actually leads to a very rather difficult question when it comes to probability and mathematics in general. But simply put, if it's a fraction or there's a decimal, then you can consider it to be a continuous number. For example, what is your R-score? Well, you can go to several decimal places. How tall are you? And it's true that somebody could be exactly, well, they might say they're 6 feet tall, it'd be 72 inches, but there's nobody that's exactly 72 inches. It's just a question of precision. So you might be 72.3, 4. And you sort of imagine it this way, is if you had a laser or some method to measure exactly the height of somebody, you could always just keep going with various decimals. So to be really precise about this, kind of technical, continuous numbers are really what we call a real number. Like, for example, that pi, 3.141592, and then it just keeps on going, depending on how precise you want to be. Everything else is discrete if it's not a real number. But for the kinds of questions I'll be asking you, it's usually pretty obvious, discrete or continuous. Incidentally, we'll have to deal with these questions very differently. And Excel does that too, by the way. Just to give you a little bit more of a sense of what's going on here, for example, and this is going to be a random variable now, if I roll a die, well, you get a 3. Well, you could get a 1, you get 2, 3, 4, but clearly that's a discrete number. But what happens if I were to say, well, roll 2 die and then average the numbers? Well, in this case, I'm going to roll, say, 2, I get a 5, well, I could get 3, I get different numbers. But imagine I get a 5 and then I get a 4 for the two different dice. Well, the average would be 4.5. 9 divided by 2 is 4.5. And that 4.5, even though it has a decimal, in actual fact, would be considered to be a discrete variable. The reason for that is that 4.5, well, then after that, it would just be zeros. So the issue really is whether you have repeating or non-repeating numbers in the decimal place. But as I say, to keep it simple, a discrete number is like an integer, it's a whole number, and a continuous number is basically anything with a fraction or a decimal place as possible. Okay. Time is a rather complex question. And if you think about it, is it continuous or discrete? Well, time, it flows along and like a river, so of course it's in that sense it's continuous. And really that's the meaning of continuous, whereas discrete would be, well, we measure time in years. So, for example, if you give your age, well, you're how many years old? Well, that's a discrete number. That would be treated as discrete. But young children, for example, if you ask them how old they are, and they'll say, well, I'm not 3. Are you 3? No, I know I'm 3.5. Well, the fact that they say 3.5 is the indication is that in fact the time is a continuous variable. But we often treat it as discrete because we want to measure it in something like years or The next question I want to look at is the issue of interval or ratio. Incidentally, the distinction between discrete and continuous is very important. Interval or ratio is perhaps less important, but nevertheless, it's a question. It's something you have to take, particularly setting up polls or surveys. It only applies to quantitative variables, so it has no relevance for a qualitative variable. Interval, a ratio number, is one that has an obvious zero to it. So for example, how old are you? That's going to be a discrete if we measure it in years, and it's quantitative, and it's a ratio number because zero has an obvious meaning. That's when you were born. And the real sense of it, though, is that if somebody is 16 and another person is 8, then we can say that the person that's older is twice as old as the other, and that actually means something. So anytime the ratio of the two numbers has some kind of sense to it, you can sort of say that, well, this means 2 times that, then we call it a ratio number. But a good guide is if there's an obvious zero. How much money do you have? Well, if you have $1,000 and somebody else has $2,000, well, then they have more money than twice as much money as you have. And if you have zero money, that means you're broke. You've got no money. It could also be, and some of these numbers can be negative. That's possible. But interval number is basically anything else, but an easy way to get it is that there's no obvious zero. And temperature is a good example of this. It happens that in the Celsius system, zero means freezing water, but it really is just arbitrary. In the Fahrenheit system, zero doesn't have the same meaning. And furthermore, if you think about it, yesterday it was, say, 10 degrees, and today it's 20 degrees. Well, we can't say that today is twice as hot as yesterday. It just doesn't mean anything. So numbers that have no obvious zero, where the ratio doesn't mean anything, then they're called interval numbers. Uh, this is very important for probability theory. It's also very important in numbers in general. It's also important in entering data into a computer. The issue is whether the number is exclusive, mutually exclusive. That's the term that's used, mutually exclusive or not. I'm going to give the example of a qualitative variable because this should be quite plain to you. If I ask you, what is your country of birth? Well, this is a variable. I don't know until you've told me, but it's going to be a country, let's say. Well, you can't be born in 2 different countries. Like you're either born in one country or another. Like somebody born on the border, I don't know. But even then they would say, well, you're defined as being born in one place. Whereas if I ask you your country of citizenship, that's your nationality, what passport do you have? Well, you could have more than one. And frequently people have more than one passport. So that means it's not mutually exclusive. So we call a variable that's mutually exclusive is that once you've answered the question or given the value to that particular variable, it can have no other value. It can't have 2 or 3 simultaneous values. Another example might be language. What languages do you speak? Well, if you speak more than one language, then it's not mutually, not even if you don't, but asking that question is not mutually exclusive. This is a very important concept in probability theory because if you imagine a value as being mutually exclusive, we'd say an event, it means any other event is impossible. If you draw, for example, the king of spades from the deck of cards, well, once you've drawn the king of spades, it's impossible that you simultaneously have the queen of hearts because you took, so we call that a mutually exclusive event. Take this as an example here. How many languages do you speak? Well, that's going to be a quantitative variable because I'm asking you the number and it's mutually exclusive. You can't speak 3 languages and 8 languages. That's not possible. It's either one or the other. But if I asked you what languages do you speak, well then that's going to be a qualitative variable and it's not mutually exclusive. Very often what they'll ask in a survey to overcome this problem of language is to say, well, what language did you first learn and still speak? That turns the question or the variable into a mutually exclusive variable. The last one I want to look at, the last 6th question, is the term of, is it dichotomic or not dichotomic? And this actually is extremely important in a lot of surveys in social science, and it has various different names. It's extremely simple to understand too. A dichotomic variable is one that has only 2 possible values. The answer can be, for example, yes or no, on or off, 0 or 1, left-handed or right. Has a whole variety of possible answers, but in all cases, it's just one of 2 possibilities. A non-dichotomic variable is basically any other variable that's not dichotomic. many political polls, they operate this way. They will ask a question, are you going to vote for a particular candidate or you're not going to vote for this particular candidate? So it becomes dichotomic. There's many names for this dichotomic. Here's a few. Incidentally, dichotomic comes from Greek. Binary is the Latin equivalent. So like a bicycle has two, dichotomic, dielectric, I think. In economics, we often refer to it as a dummy variable. Sometimes we call it a fictional variable. Computer people often refer to a Boolean variable. It's after a mathematician. A binomial distribution, binary distribution, all of these mean essentially the same thing. We're talking about a variable that can have two possible values. So let's important little distinction here of this concept is a false dichotomy would refer to the idea that somebody presents to you the idea that you have a choice between A and B, implying that it's a dichotomic question, when in fact it's a false dichotomy because you have options C, D, E, and F. So be very cautious about anybody making an argument where they come say that we should either choose this or that, and you have no other options. Often you do have more options. So we refer to this as a false dichotomy. A Hobbesian choice is sometimes similar. It's the idea that, well, I'm offering you these two possibilities, but it's really no choice at all. It's like saying you can have this or I'm going to shoot you. That's a Hobbesian choice. And it's similar to a false dichotomy because there may be other options possible. The seventh question, and I'm going to look at this a little bit more carefully later, but is the variable random? And this is a broad concept, and when we talk about a random variable, we often refer sometimes as a statistic, whereas a non-random variable is sometimes known as a fixed parameter. But as I say, the quiz you've got to do, it's only the first 6 questions that matter. I'll give you an example of the distinction here a little bit is the idea of what is the temperature in Montreal tomorrow? Well, I don't know exactly, but I can make a guess. So it's in that sense, it's a random variable. We'd say it's quantitative, and then we'd say it's continuous, and it's mutually exclusive, at least if we're measuring the temperature in one place. But if we were to say whether we measured in Celsius or Fahrenheit, that doesn't really change anything, except if we want to convert between the two, we would use fixed parameters to do that. And I don't know if it's to double the temperature and add 32 or something. There's some formula for switching between them. And the formula that goes into it is a fixed parameter. They don't change. Another example here is 2. It's kind of interesting. Here I've given an example of x. Let's call it a random variable. I'm going to go through this little formula and explain each of the terms. X it's a variable. The little symbol there means it's a random variable. The B indicates that I know it's a binomial or a dichotomic variable. And the little half is a fixed parameter, in this case, telling me what the distribution is. In this case, x is a random variable binomial that represents the flipping of a fair coin. You can get heads or tails. There's only 2 possibilities. I'm excluding the possibility of just landing on its side. And since it's a fair coin, you've got a 50-50 chance, and that's what the half parameter would represent. So let's summarize all of this. And I've reversed these questions a little bit. The first question you should ask yourself, is it dichotomic or not dichotomic? If it's dichotomic, that means to say it can be either 1 or 2, A or B, heads or tails, left or right, yes or no. And then you can stop immediately, because all of the other questions are completely irrelevant. You can just enter not applicable for any of the others. But if you determine that the variable is not dichotomic, meaning you say there's more than 2 possible choices, then you have to go through it carefully and consider them. First question is it qualitative or is it quantitative? So qualitative is like a word type answer, high color. Quantitative is a number type answer. If it's qualitative, you have to determine whether it's nominal or ordinal. Nominal means there's no natural order. Ordinal would be something like the size of a drink or the gear shifts that you may have when you're changing gears in a car. And then if it's quantitative, on the other hand, you have to decide whether it's interval or ratio. Ratio means that there's a natural 0. Twice 1 means it'll be 2 times whatever the other number may be. Discrete or continuous, again, only applies to quantitative. Discrete means it's an integer, a whole number. Continuous means you could have fractions or decimals and so on. And then lastly, which applies to both, whether it's qualitative or quantitative, you have to determine whether it's mutually exclusive or not mutually exclusive. Mutually exclusive is the example of what country where you were born. There's only one. If you have a value, it's only going to be one value. Not mutually exclusive means that the value could be, the variable could have several simultaneously, several values. Like what languages do you speak? In which case, the person could answer several things.